In this video we will be discussing confidence intervals for means. This will continue our discussion on confidence intervals. We have our general form for our confidence interval that we introduced last time when talking about proportions. A confidence interval is going to be some statistic, that is a number from the sample, plus or minus some margin of error. Alright, for means we're going to be dealing with a specific confidence interval, and that confidence interval is called a one sample t interval. One sample t interval. Okay, and this one sample means we're interested in only, we're not comparing two different groups to each other. We're interested in finding and estimating one parameter. We want to know what in the video that we just looked at, the average size of the apple. Okay, we want to know what the average height is of adult American women. We're interested in estimating one single parameter. All right, and it's a t interval. We're unsure about the nature of the underlying distribution. All right, we're constructing a t interval. All right, this interval will look like this. The statistic, since we're talking about mean, is x bar. That's our sample mean, plus or minus the margin of error. The margin of error, well, in general, it is a critical value times a standard deviation of a statistic. Okay. This is the general form of our margin of error. In the particular case for our one sample t interval, the critical value is going to be a t critical value. And we'll discuss more about that in a second. T critical value. The standard deviation of the statistic, as you saw in the previous video, is going to be the sample standard deviation, S, divided by the square root of n. Alright, so this x bar comes directly from our sample. The standard deviation comes directly from our sample standard deviation. N is simply the sample size. The only thing left we have here is this t critical value. Well, two things. Number one, it's going to be based on a degrees of freedom. Okay, and the degrees of freedom is simply the sample size minus 1. Okay. Also, it's going to be based on our confidence level. Confidence. It's going to be based on the degrees of freedom and confidence level. That is, are we seeking a 95% confidence level, a 90% confidence level, whatever it may be. So with these two pieces of information, we're simply going to reference a table, again, as they stated in the video. Using the degrees of freedom and the confidence level, we will look at a table. Alright, now let's see if we can see some problems directly from our homework. Our homework in this section is going to be page 504, 505, and we will be looking at 12.19 through 12.25. .27. While not in our assignment, this problem is identical. It is like 12.19. Okay, it says, what percentage of time will a variable that has a t distribution with the specified degrees of freedom fall in the indicated region? A asks, we want 10 degrees of freedom, and we want to be between negative 2.23 and a positive 2.23. Alright, to answer this question we simply need to consult a table. a table on the t-distribution. I'm going to Google t-distribution, and I have clicked on Wikipedia's table. You can find in any number of these tables. Alright, so notice at the top of this table it says one-sided and two-sided. Okay, when we're constructing a confidence interval, it's two-sided. We say plus and minus. Alright, so I'm going to be interested in this two-sided part. And these numbers down the side are simply my degrees of freedom. So in this problem, we were looking for 10 degrees of freedom. I'm going to be on this row. And I'm going to go until I see the number 2.23. So I'm scrolling across, and here is 2.228. That's close to 2.23. And going up to the top, I see that's 95% confidence interval. So our part A here says, what percentage of the time will it fall in here? Well, for this one, it's going to be 95%. Okay, that's the answer on to A. Love you. B. It says 24 degrees of freedom. 24 degrees of freedom. Remember, all this degrees of freedom is a reference to the sample size. Again, degrees of freedom is equal to n minus 1, where n is the sample size. To say 24 degrees of freedom means we had a sample of size 25. All right, and we want our t statistic to be between negative 2.80 and a positive 2.80. All right, so again, back to the table. I want to go to 24 degrees of freedom. Here's 24 degrees of freedom. And I'm going to find the 2.8. There it is. There's 2.8. I'm going to scroll up to the top of the table, looking at that column. And that is the 99% interval. So this one is 99%. All right. C. 12.28. This is going to be like 12.20. All right. 12.28 says, from our formula, our one sample t formula, which is x bar plus or minus our t critical value, times our sample standard deviation over square root of n. Okay, what is the appropriate t critical value for each of the following? So we're looking for this t critical value. A says we're looking for a 90% confidence level. A 90% confidence level, and we have an n equal 12. All right. Well, we're looking for this. We're looking for this t critical value. Remember from earlier in our notes, this t critical value is a function of two things. It is dependent on our degrees of freedom, which has to do with our sample size, and our confidence level. And once we have these two things, we're simply going to look on that table. All right. So our confidence level is 90%, and our n is 12. This is our sample size. Thus, our degrees of freedom is 11. 12 minus 1. 11. Degrees of freedom is just our sample size minus 1. Alright, so we have our 90% confidence level. We know our degrees of freedom. Now we just reference our table. Going back to this Wikipedia. Nothing special about this Wikipedia table. You can find this table in many locations. So I'm going to 11 degrees of freedom. And then I'm scrolling over until I get to the 90%. Again, we're talking about two-sided. It's a confidence interval with a 90%. So 11 and 90% intersect at 1.796. All right. Thus, our T critical value is approximately 1.796. Okay. And you should be able to assist with this assignment. I'm going to do 12.21. This is directly off of your work. 12.21. Okay. 12.21 says we have two intervals. We have the interval 114.4, comma 115.6. I'm going to call this interval 1. And we have a second interval, 114.1, comma 115.9, interval 2. All right. These two intervals are for the mean resonance frequency for all tennis rackets of a certain type. Okay, so the two intervals are calculated using the same sample data. So these two intervals came from exactly the same. We took some tennis rackets and we measured them. It doesn't tell us how many. Okay, we measured their frequency and we came up with these two intervals. So why are the intervals different? All right. Well, first of all, it came from the same sample. Thus, they have the same sample mean. So this x bar is going to be the same for both of these, which means they should be centered on the same value. And if you add these numbers together and divide by 2, you'll see that's the case. 114.4 plus 115.6. If you divide that by 2, you will see that the center here is 115. Same way for this one. They're both centered on 115. Why are they both centered on 115? Because they came from the same sample data. X bar is the same in both cases. So both of these intervals have the same X bar. All right. What is the value of the sample mean resonance frequency? We just found that. A. X bar is equal to 115. Okay, and how do we find that? The sample statistic is the center of the confidence interval. So if you add these endpoints together and divide by 2, you'll see that they're both centered on 115. It makes perfect sense. Our confidence interval will be centered on what that sample statistic is. Okay. B, the confidence level for one of these is 90% and for the other is 99%. So which one of these is 90% and which one is 99%? Well, we know that the only difference between these two, we know x bar is the same, we know the sample standard deviation the same, and the n is the same because they came from the same sample. So the only thing that's different is this T critical value. Well, the T critical value deals with the confidence level and the degrees of freedom, but we know the degrees of freedom are the same, so the only difference is the confidence level. So, which one's 90 and which one's 99%? 90% confidence and 99% confidence. Well, this is going to make perfect sense to you. To be more confident, we would need to reach out further. We would need a wider interval. So you see interval 2 has endpoints that are wider. If we have endpoints that are wider, we're going to be more apt to capture our true mean, the population parameter. So clearly the 99% confidence would be from interval 2. Interval 2, and the 90% confidence is from interval 1. Okay. And the reasoning is as the confidence level increases, the width of the interval will increase. If everything else is held constant. All right. With that information, okay, we're going to be doing through 12.26. I made a mistake on this. 12.26 will be the end of this assignment. All right, I'm going to do one more problem, and you should be in pretty good shape from here. I'm doing 12.31. This is not from our assignment, but this will be very similar to 12.23 and 12.22. This is like 12.22 and 23. This is going to be the actual constructing of the confidence interval, so the main focus of this assignment. It says, getting to the question sentence, use a confidence interval to estimate the mean breaking force for the acrylic bone cement. Acrylic bone cement is sometimes used in hip and knee replacements to secure an artificial joint in place. The force required to break an acrylic bone cement bond was measured for 6 specimens. So we have, in this case, we have N of 6. So what we're going to do is we have 6 samples. We're going to try to find the entire population parameter. That is how this acrylic performs for everyone based on these 6 samples. So right there you can see that our sample size is relatively small. So we have to be, perhaps a little suspect about our results. The force required to break an acrylic bone was measured for 6 specimens, and the resulting mean and standard deviation were, so we're giving a sample mean of 306.09 newtons and a sample standard deviation of 41.97 newtons. Okay. For the sake of our calculation, I'm going to do some rounding here. I'm going to call this approximately 306, and I'm going to call this approximately 42. I think you can see. Should we always do this kind of rounding? Not necessarily. It wouldn't be too hard to use these numbers, but I'm going to make this change here for the sake of the video and simplifying our life a little bit. Well, first let's begin with our interval. Okay. We know that in general it is the statistic, it's the stat plus or minus some margin of error. But for our particular t, it's going to be our stat is x bar plus or minus. We have our t critical value. No point there. It's just a t critical value. Times our sample standard deviation divided by the square root of n. Alright, well we have all these ingredients in this case. Our x bar is 306. X bar is 306. That's where our interval is going to be centered. Plus or minus. This t critical value is a function of our degrees of freedom and our confidence level. It doesn't give us any confidence level. In lieu of a given confidence level, we're going to use 95% as our default. We're going to do a 95% confidence. That's oftentimes that's the standard of 95%. We want to be correct 19 times out of 20. Okay. So we're going to do 95% confidence, and we know that our degrees of freedom is equal to 5 because our sample size is 6. So back to our table. Alright. We want a 95% confidence. We look at our two-sided 95% confidence, and we move down the table until we see 5 degrees of freedom, and that is 2.571. You see right there. It's the intersection of 5 degrees of freedom and our two-sided 95%, 2.571. Okay. So our T critical value is 2.571. Our sample standard deviation is 42. And our square root of n, that's our sample size, that is square root of 6. Alright, so now it's just some calculator work. 306 plus and minus, using your calculator to evaluate that value. So my margin of error was 44.08. Alright, this is one perfectly legitimate way to express the confidence interval. Equivalently, we could write it using the interval notation. We'll do 306, subtract that number. That's 261.9. And 306 plus that number would be 350. It's actually 3.08. I'm going to use one more decimal here, 0.1. 0.2 is what it rounds to. So 361.92 to 350.08. That's an equivalent way to express that interval. And then we write what it is that we are indeed estimating. So we say we are 95% confident. We are 95% confident the mean, that's what we estimated, the mean, and it's the population mean we're talking about, not the sample. Okay. The mean force required to break an acrylic bone cement bond. The mean force required to break an acrylic bone cement bond. Measured in newtons. Lies in that stated interval. Lies in 261.92 to 350.08. Okay. What does that mean? We're 95% confident. Does it mean there's a 95% chances in there? No. It's either in there or it isn't. But this method that we've done, if we do it over and over again with samples of size 6, and we continually do that, 95% of our intervals will capture whatever that true mean is. We don't know if this interval did it or not, but this method would work in 95% of the cases. Alright, with that you should be able to answer the rest of the problems on this assignment.